Okay, so on the set 8 now, imagine this is like a big metal plate, all right? And we're going to cut a hole in it. Everyone see the hole that I've cut in it? Okay. Can we find the area of the shaded bit here? What do you guys think? Okay, without being too specific, how? Yeah.
Times 8 by 10, and then 6 times 2 is minus it.
Okay. That was good. That was more specific than I even thought. Zane, were you going to be that specific? Pretty much what she said. You guys are good. I was even hoping for just take the area of the big part and subtract the whole. What do you think? Is that it? Okay, well, can we do the area of the entire plate? Oh, I didn't tell you what it was. This better be meters. This is a big piece of metal. 8 meters times 10 meters. That's the area of the whole thing. And you guys know that 8 times 10 is 80. What's meters times meters? It's square meters. We need to talk about that a little bit. What's 4 times 4?
16.
It's 4 squared.
That's not how this goes. It's
Wait a minute. Isn't it?
It
No.
is.
No, 16.
It is. It's 4 squared. What is 5 times 5?
5 squared.
It's 5 squared. What is x times x?
X squared.
It's x squared. What is feet times feet? It's feet squared. We don't say it. We say square feet. Okay, but the units have to work out. Okay, so when we go length times width, we end up with squares, right? And then we're going to subtract the 6 meters by 2 meters, which is 12 square meters, and there we have 68 square meters, and that's the area of the shaded part, isn't it? What do you think? You okay with this?
Yes.
Everybody?
Yeah. Is that
Okay.
what you want it written down?
Yeah, that's what I want to see on your paper.
Okay.
Right here. I want the picture of it. I want to see what you did, because if you just give me an answer, I can't help you if it's wrong. Can I? I have no idea what you did wrong, and I can't help. Okay? All right, so I think rectangles you guys are good with. Let's talk about triangles for a minute. Anybody know the area, the formula for the area of a triangle? Yeah? Zane, you?
Isn't that the one that you divide in half?
What you do is that you take the two on the sides, add them up, then take.
Yeah, sorta. Yeah. And the one that maybe we divide by 1/2, and yeah?
1/2 times base times height.
1/2 times the base. Ooh, I like that. Sometimes I hear base times height divided by 2, which is okay, but we're big boys and girls now. We're in algebra. It's half the base times the height, and I'll show you why. Okay? Every single time I look at a triangle, now this one's a right triangle, okay? Let's say its base is 10 and 8 inches. If we take 10 inches times 8 inches, okay, well that's 80 square inches, isn't it? But I'm going to say that would be the area of this rectangle, like the whole thing, wouldn't it?
Yes.
But the triangle is half of that, isn't it? Okay, which is half. Okay. Now, I want to show you something. If we take half of 80, of course we get 40, right? Okay. But what's half of 10?
5.
What's 5 times 8?
40.
Okay. What's half of 8?
4.
What's 4 times 10?
40.
Does it matter what order you do this in?
No.
Now that can be really, really nice, okay? Because if you have a triangle, now I'm not going to draw a right triangle this time. This one is an acute triangle. Its base is 17, and its height is, I don't know. Maybe I did a bad thing here, but anyway, what does that look like? 12. Fine. Okay. So this is in inches, so half the base times the height. Okay, anybody know 17 times 12?
No,
No. Anybody know half of 17?
no,
No. Anybody know half of 12?
6.
6. Okay, so 17 inches times 6, we can do that. We can do it that way. And that might be a little bit quicker, right? Because I think you guys can do this. What's 6 times 10?
102.
Isn't that 60?
Yeah.
And what's 6 times 7?
42.
42. And what's 60 plus 42?
102.
102. And what's inches times inches?
Square inches.
Okay. Now, let me warn you about something. You don't go half of 17 and half of 12. That's double dipping. Okay, one or the other. Right? Like if I gave you 3 times 4 times 5, you wouldn't go 3 times 4 and 3 times 5 and then multiply the answer together, would you? No. Okay. Okay, well, I think you guys are pretty good already at rectangles and triangles, right? So how about a rectangle with a triangle out here connected to it?
That's when you got to make it, you got to cut it.
So is there a formula for this shape?
No,
There actually is. It's called the trapezoid. There's a formula for it, but I don't think any of you know what that is. But like Derek's saying, can we divide this up into 2 things we can deal with?
yes.
What 2 things?
Triangle and a rectangle.
Yeah. Right? Okay, can we find the area of the, let's just do the rectangle. Tell me its dimensions.
40.
We'll say this one's in centimeters. What is it?
40.
Wait a minute. What are the dimensions of the rectangle?
Oh, 6.
So what I mean by that is, what's its length and width?
4 and 6.
Okay, so 4 centimeters times 6 centimeters. That's what I mean. When I say what are its dimensions, I mean what are its length and its width. So I can do something, right? So this is 24 square centimeters. And then what about the triangle? What are its dimensions? And I mean, I'm talking about the base and the height, the 2 I need to do something with, right?
And 4.
Now, ooh, I heard a 10 and I heard 4.
No, it's 4 times 4.
This part's 6, isn't it?
Yes.
So,
Oh, yeah.
4.
does that make sense?
Yeah.
It's so easy to go 10 times 4, isn't it? Now this is a right triangle. So half of 4 times 4. What's half of 4?
2.
2 times 4? 8. What's 4 times 4?
16.
What's half of that?
8.
Doesn't matter what order you do this in?
No.
Okay, so we have these 2. Now you can't forget the whole area is those 2 together, right?
Yeah.
So 24 plus 8.
2 centimeters squared.
And you should have at least a capital A to say that's what the area is. So you're good at rectangles, you're good at triangles. Can we put a rectangle and triangle together and you can find the area?
Yes.
Okay. Okay, now, circles. Who's done the area of a circle before? I think you've all done it. You've all learned about it. I bet you've had a teacher that's talked about it before, right? Okay. So I'm just going to draw a circle here. This is the radius, correct?
Yep.
And then if I go all the way through like that, what's that one called?
Yeah.
I'll put capital D for diameter. So, fortunately for you guys, people have been doing the area of a circle for a long time. Okay, thousands of years. And there's different ways to look at it and estimate what it is. I think I have one here. So I have this circle. I divided it into some parts. So I don't know if you can see that real well. Yeah, here. What I did was I just started dividing the circle up. And I believe I divided this one up into 8 equal parts. Okay? And then what I did was I cut this circle up and just made a bunch of little pie shapes. Now, does that look like a triangle?
Yes.
Is it a triangle?
No.
Now, it's a little curvy here on the end, isn't it?
Yeah.
But if you back up a little bit and squint your eyes, is it a triangle?
Yes.
Let's say it's a triangle. We're just going to say it's kind of a triangle, okay? It's kind of a triangle.
It's a cone.
So, we can take all 8 of these triangles and we can put them together in a different way. And this one's stuck. I don't know how that one got in there. But it's not being very happy about coming out. Okay, there we go. So I put them together in a different way. You see that okay?
Yeah.
Now, that doesn't look like something very good, but let's take that last one. I'm going to divide that one in half. I'm going to put half of it over here, and I'm going to put the other half here. Okay, is this starting to look like a rectangle a little bit now?
Yeah, maybe a little bit.
Kind of like a rectangle. Okay?
That's good.
And this distance right here is the radius of the circle. Do you agree with that? From the center of the circle straight through to the edge, that's the radius. And this piece up here, it's actually half the circumference. It's not the whole. Like if you took all the curvy edges all together, wouldn't that be the whole circumference?
Yeah.
So this is half the circumference and this is half the circumference. What do you think about that? I'm making you think a little bit here. This might be above your pay grade here for a minute, but you can do it. Okay? Everyone agree that half the circumference is across the top and half of it is across the bottom?
Yes.
Do you remember what circumference is? Do you guys remember the formula for it? Diameter times pi? Diameter times pi. There's another way we say circumference. What is that one?
2 pi r equals
2 pi times the radius. Okay. So if the circumference is 2 pi times the radius and this distance across the top is half of that, what would half of 2 pi r be? 1 pi r. Awesome. 1 pi r. And I'm not going to worry about this one because I'm doing the area of a rectangle. Right? And how do we find the area of a rectangle? We go length times width, or height. I'm going to say width. Is that okay? All right. So if I take pi times r times r. Now wait, I think you guys know what r times r is. No. R plus r is the diameter. What's r times r? R squared. So the area of a circle is pi times r times r. Pi r squared. Okay? And that's it. Can you imagine how smart the guy was that figured that out? Came up with that formula? I bet you're glad your assignment today wasn't to figure out the formula for the area of a circle. Right? All you got to do is figure out how to use it. So now that you know that the area of a circle is pi times r, or we're too lazy to write that, so we put r squared. Okay? If I tell you the radius is, I don't know, 3 inches, can we do this? Pi times what? 3 inches times 3 inches. Okay, well that's pi times, what's 3 times 3? 9. What's inches times inches?
Inches squared.
Okay, well that's good because aren't we looking for area?
Yes.
By the way, isn't it weird we measure the area of a circle with squares?
Yes.
This one back here is weird.
It is a little weird there, but it's probably easier than measuring the area of everything in the world with circles. Okay, so that's the alternative. Okay, now I don't like this. I don't like pi times 9. I don't think that's a good way to write it. How should we write that?
9 pi
9 pi.
inches squared.
Now this looks like a lot, I think. But when it comes down to it, it's not that big a deal, is it?
No.
By the way, what is the diameter of this circle? Whoa, whoa, whoa. What? 6? 6 inches? So what is the circumference of the circle then?
6 pi.
6 pi? Now, we can get out our calculator and we can go 9 times 3.14. And that's approximately what the area of the circle is. 28.26 square inches. Here. See that square right there? Square inches, right? 28 and a little more than half of one. Okay? But is that the exact answer? Is this the exact answer?
No.
Why not?
Pi is bigger.
Because pi is not exactly 3.14. Okay? So, am I letting you use calculators right now?
No.
No? So look at that answer right there. Is it exact?
Yes.
Was it hard to get?
No.
Okay, so let's go with that. Got it? Same thing for circumference. We just give our answer as that's the exact area. That's the exact circumference. Okay, so here. You guys know the formula. There's two formulas. Circumference. I'm gonna write. I shouldn't write it like that. I should write this way. And then area pi r squared. So here's a circle. I'm going to tell you the diameter this time. I'd like you to find the circumference and the area. You don't even have to draw the circle this time. I've got it for us.
Inches, right?
What's that?
All centimeters.
Oh. You done? Did it take long? Okay, so should we do circumference first since we already know the diameter? Diameter times pi. Everyone got the units in there?
Centimeters.
Did everybody put the 14 first and then the pi second?
Yes.
Don't put pi 14. That's like writing x14 instead of 14x. So we're using pi like it's a variable. We want to put it second. Okay? Okay, radius,
7.
7. So when you get a problem like this, you're going to draw the circle and you're going to label the diameter and the radius every time. It'll give you one of the two. You label the other one also, okay? So the area is pi times 7 centimeters squared. That's what the formula says. So you can't go pi times 7 and then square that. That's not the same thing. You got to go 7 times 7 first. What's that?
49.
49 times.
Pi.
Then you can multiply by pi. And what's centimeters squared?
Centimeters squared.
Yeah, it's square centimeters. And those are the exact answers. Okay? The formula, we got a poster for it. If you look in the very back of your book, way back here. See that? There's the formula. Area and circumference formula, right there. It's always right there. Okay. We're going to begin set 8 today. Well, the assignment is 1 through 30. I don't think we're going to get done today. Ooh, I don't know. We might. We might. We've got 30. Oh, we got 40 minutes, don't we? We actually have time to get this done in class. Go! Work like the wind!